There is like something on the chat, like give me a sec. Yeah, I also wanted to mention that for the previous problem, water and jet problem, when I was like looking into it, there is also a mathematical formula that can lead us to a very fast solution using GCD. Okay, I will encourage like people to read if they're interested about it. Okay, so let's jump to the last question for the day. This question is, find the longest substring with at least k repeating characters. Okay, so first example is, let's take like different examples like to clarify the question first. It's always like good to ask the clarifying questions given k equal to 3. Okay, so we need to find a substring in AAABB which have at least k repeating characters. Okay, so the solution here is AAA. We cannot include B's because their count is less than k. Okay, what about if the string is AAABBB? What should be the answer in this case?
The answer could be 7 because 4A, the frequency is 4 and it's larger than K 3, and the frequency of B is also 3.
Yep. So the whole string can be the answer because we have like 4 A's which is greater than 3, and we have like 3 B's which is equal to 3. Okay. What about AB? In this scenario, what's the count of A?
3.
3, and count of B? 3.
Yeah, it's also 3.
Yeah. So the answer is 6.
6. Yeah.
Okay. Because the question says we just need to count the characters if they repeat at least k times. They don't need to be adjacent, they can be anywhere in the string. Okay, now what about, let's say I insert C in between.
It will be 0. Oh no, 6.
Why?
Yeah. From the ABAC EA.
Okay, so here can we include C in the solution?
No.
Okay.
Yeah, we cannot include the C, so the answer will be 0.
Yeah, we cannot include C in the solution, and the question clearly says it should be a substring, not a subsequence. Okay, so we cannot have, the answer here is 0. Okay, what about, let's take like the second problem. Second example, ABB, C, and K is 2.
The answer will be 5.
Yes, because we can include all A's and all B's. There are 2 A's and 3 B's, and C is less than K, so we don't want to like include C. So hopefully question is clear to everyone. I will take silence as yes. Any approach? How we can solve this problem? Can you guys still hear me?
Yes.
Okay. Sometimes I feel like silence, maybe I lost everyone. So any approach. It can be brute force approach, any approach. So what can be the brute force approach?
The brute force could be iterate the whole string, and for each length, count it every character's frequency. If every every character frequency is larger or equal than k, yeah, it will be done.
Yes, which is correct, because given, let's say, this example, okay, K2, we know like we need to have a string with at least size 2. So we can come up with all the substrings within a given string of size 2 and then see if the conditions are matching. So in this case, we can have AB as a first string, then BA, then AB, then BB matches 2. So at this point, we got the answer as 2, then BC, then have length 3 strings, ABA. Yes, this doesn't matches because like B is of size 1, BAB, we cannot include that, ABB, we cannot include that, BCC, we cannot include that. Have a string of size 4. ABAB, can we include that? Yes.
Yes.
Okay, so we got updated answer, which is 4. BABB, we cannot use this as an answer. ABBC, we cannot use that as an answer. Okay, we are done. 5. Okay, 2 A's, 3 B's. Yep, definitely we can include that as an answer. So our result is 5 now. And then BA, BBC, we cannot include because A and B, A and C counts are less than K, less than 2. So we cannot include that. So that's one possible brute force solution. Come up with all possible substrings greater than or equal to K and less than the, yeah, greater than or equal to K, and then count the character, count the frequency. Yeah, thanks for suggesting that. What can we do better here?
Yeah, so we count the character and separate the character that less than k versus the character that bigger than k, and we iterate through the string. You know, as soon as we encounter the character that less than k, and we stop.
Okay. So
yes, you can break there and start again.
So let's take this example where let me take this and k equal to 2. So what should we do here? Can you please like repeat the algorithm that you mentioned about the approach?
Yeah, we would count the character. I'm sorry, I'm driving right now. I cannot see the screen.
Okay.
But mainly we count the character and separate the character that's greater than or equal k versus the character less than k, and then we iterate through the string from left to right. As soon we encounter the character that's less than k, then we stop.
Yep. So that's a good approach. So I will like repeat the approach. So what we are talking about, given a string, we count all the frequency of all the characters. So what's the frequency of A here? 4. Frequency of B? 4. Frequency of C? 1. So what this map indicates us, what's the idea?
There could be a solution before C or after C.
Yeah, so this indicates like C is a bad character here. We can have like more characters. Let's say we have like D, okay, but I'm just taking like a simple example, or let's include D also. D equal to 1, okay. So we have a D here, right here. So this indicates both C and D are bad characters, okay, because their frequency is less than 2 and they cannot be in the solution. Okay, so given this string, what if we break this string by first bad character that we found? It can be any, like, okay, so what if we break it by C?
We divided the whole string into 2 parts.
Yeah, 2 parts. Yeah, so this is the left part.
Yeah.
And this is the right part. Okay,
Mm-hmm.
now we divided our problem into 2 similar subproblems, right?
And recursively
Okay.
do the same thing to the left string and
Yes.
the right string.
Yes, we will do that. So let's say let me take a different example. I have AB here, and let me insert D here. AB. Okay, so in this case we have, let me break it down first. See, frequency of C is 1. Okay, correct. Frequency of A is 1, 2, 3, 4, 5, 6. Frequency of B is 1, 2, 3, 4, 5, 6. Okay. Frequency of D is 1 and 2. Okay. Frequency of D is 2. Okay. And given this string, now what's the known bad character here? C, right? So let's divide this string into 2 parts. Based on C. So we got 2 sub problems. If we take then we look into each sub problem separately and then combine the result, like whichever has the greater result. Now on the left, what's the frequency of A? 2.
2.
Frequency of B?
2.
2. Okay, and the string length is 2. Okay, so we got like one possible answer as 4.
Mm-hmm.
Right? Now on the right, what's the frequency of A? 4. Frequency of B is 4. Frequency of D is
2.
2. Okay, what should we do here then?
Then the answer will be the length of the whole string. So the answer is 10.
Yep.
Because, yeah, each character frequency is bigger than K or
Yeah.
equal than K.
Yeah, at least 2 there.
Yep. So the answer that we got here is 10. And then we look into what solution, like what's the answer that we get from the left subtree, what answer we get from the right subtree, and take the max of that. So in that case, it's 10. Okay. What if on the right subtree, let's say we might have, I'm just like assuming we might have like E here in the middle. Okay. Then we have to again
Split it.
repeat the same problem. Okay, let me write it separately here for the ease. And then we have to take this substring and then remaining substring. Okay. Now on the left, we will again break it down by D because D's count is less than 1. Okay, so we will get BA. And on the right also, like we will get BA. So both of those leads us to answer of
4.
4. So this is the approach that was suggested, and it's divide and conquer. We can keep dividing, finding the bad character, and then divide the string, find two sub problems, similar sub problems, repeat.
So
Any
it's
question?
what would be the complex? We are iterating the string again and again. Substring.
What should be the complexity? Anyone?
Mm.
So let's say
It will be
yeah, go ahead.
n plus n by 2 plus n by 2, then keep maximum every time it's by half. So we have to keep on going till n.
Yep. So
Like n to n by 2.
think this as very similar to like you're constructing a tree in a case where there is a perfect split. Let's say you are splitting the string right in the middle. Okay, so the left subtree and the right subtree, they have similar nodes. Okay, which is kind of a tree that we are constructing, like binary tree that we are constructing. Um, compare it with merge sort, same algorithm, same kind of operations we are performing. So if n is the length of the string, what should be the complexity? N log n.
Because
Yeah.
okay.
Okay. What if the split is like not even? Let's say we have this string a multiple times, b multiple times, and then we have c at the end. Okay. So in this case, we will just have left subtree, right? And then again, let's assume we come up with something. Let's say there is like something like this. I'm just like taking an example. Okay, where if you split by c first, because c is the first character that you will find when you are like creating a map, because generally like we create a map in this fashion in and this is like some Java code. Okay, counts new int 26. Okay, so we will find the first like we count the frequency, then when we are iterating to this count, the first character that will come is c. Okay, so the string is split something like this, then we will find d, then the string is split like something like this, correct? So we will have like kind of a linked list where we only have the left subtree, there is like no right subtree. Okay, what's the complexity of that? Instead of log n, it should be n.
And
Okay, so which leads us to n square.
Yeah,
I believe like in the worst case, yeah. Okay, any questions?
When I saw this question, I thought it would be a sliding window question. But then I found no, there are multiple variations that it would end up doing recursion.
Yes, there is one more approach, as Asim is suggesting. It's a sliding window approach, which can lead us to a strict order of n solution. Okay, I don't think like we have time to discuss about it, and right now I have to leave for my office too. So maybe if you guys want to try it out, give it a try, implement this divide and conquer approach, because it's kind of like a recursive approach. Come up with the base cases. Okay, it should be easy to implement, and then see how sliding window works.
Okay, cool. Thanks, Carla.
Okay,
thank you.
thank you guys. Have a good day.
Thank you. You too.